Howdy! In this mini lecture we will continue to discuss the science behind global climate change and the current and future impacts of climate change. The student learning objectives of this mini lecture are: summarize how researchers study ancient climate and outline current and future trends and impacts of global climate change. Scientists study climate change by using proxy indicators to study what the Earth's climate was like in the ancient past. The climate of the ancient past, or paleoclimate, is essential for studying climate change because it gives us a baseline against which we can measure changes occurring in our climate in present day. Proxy indicators are types of indirect evidence that serve as proxies or substitutes for direct measurements. Ice cores are a very common proxy indicator used by climate scientists. Bubbles trapped in the ice contain samples of the air from thousands of years ago. The ice is layered over time, so by studying ice cores we can determine the atmospheric composition, greenhouse gas concentration, temperature trends, snowfall, solar activity, and even the frequency of forest fires and volcanic eruptions. The image in the bottom right shows the concentration of CO2 in the atmosphere from 800,000 years ago to present day. The evidence of climate change is all around us. In 2009, the Maldives government held a cabinet meeting underwater to draw national attention to the plight their country faces due to rising sea levels. Longer heat waves, more intense storms and droughts, and increases in flooding are all indicators of global climate change. What is important to keep in mind, though, is that we cannot blame any single weather event on climate change. However, it is the patterns that have been observed that matter. The scientific body that gathers the data on these patterns, reviews, and summarizes the climate change information is the Intergovernmental Panel on Climate Change, IPCC. Their reports are composed from peer-reviewed studies completed by hundreds of international scientists. Additionally, government reports are also used in IPCC reports. Climate change data indicates the average surface temperatures increased 1.33 degrees Fahrenheit from 1906 to 2005, that most of the increase occurred in the last few decades, the 17 warmest years on record have been since 1990, that 2001 to 2010 was the hottest decade on record, and that since the 1960s each decade has been warmer than the last. In terms of precipitation, climate models indicate precipitation will increase at high latitudes and decrease at low and middle latitudes, which will exacerbate existing water shortages in poor nations. Another documented effect of global climate change is the melting of mountaintop glaciers, snow cover, ice sheets, and sea ice. The melting of global ice is most pronounced in the Arctic. As glaciers melt, additional fresh water is added to the sea, causing sea levels to rise. 77% of the country of Maldives is predicted to be underwater by the end of the century if the pattern of warming and sea level rise continue at their current rate. A recent study indicates that we can expect sea levels to rise 2.5 to 6.5 feet by 2100. While the Maldives is a far-off country that may not mean much to you, Florida is not. These projections would make Miami either a city by the sea or a city in the sea, depending on how high within the projected range sea levels rise. As sea levels rise and oceans expand because they are warmer, this will lead to beach erosion, coastal floods, intrusion of saltwater into aquifers, and stronger storm surges. Global warming also threatens both aquatic and terrestrial animals. Warmer oceans are detrimental to coral reefs, mangrove forests, and salt marshes. Coral bleaching is suspected to be due in part to warmer ocean water. Ocean acidification is another detrimental global change. The ocean has become more acidic because it absorbs CO2 from the atmosphere. This change in pH is detrimental to ocean life in that it impairs the ability of corals and other organisms to build their exoskeletons. Terrestrial animals and plants are also at risk. Humans have the ability to adapt our homes more easily than animals. We could just turn up the AC. But animals don't have that luxury. Many bird species have shifted their ranges northward in the past 40 years due to warming temperatures. Animals and plants adapted to mountain environments will be forced uphill, but at some point the birds can't fly any further north and the animals on the mountainside can't go any higher up the mountain. Plants are at an even greater disadvantage because they have far less mobility compared to animals. Their best hope is that their seeds will be transported to an area with slightly more suitable conditions. Global climate change is expected to threaten 20 to 30% of species with extinction. Societies are already feeling impacts of climate change. Climate change-induced water shortages, droughts, changes in precipitation, more intense storms, and altered growing seasons are all happening right now. Unfortunately, like many other environmental problems, the people living on the fringes of society and in the depths of poverty are the ones that will be affected the most by the effects of climate change. There are several climate change effects that have occurred, are occurring, and predicted to occur that will have significant impacts on society. Some of the more prominent effects will be seen in agriculture, public health, economics, and forestry. In regard to agriculture, farmers already have to adjust their techniques and schedule to accommodate the altered growing cycle. It is predicted that in temperate zones the growing season will lengthen, which would cause a slight increase in production. On the other hand, though, the seasonally dry tropic and subtropic zones are expected to experience shorter growing seasons, which would decrease production. The tropics and subtropics are also more susceptible to drought. Another effect is that extra CO2 absorbed by crops makes them less nutritious. Additionally, intensified droughts and rainfall will cut into production. The IPCC predicts that if temperatures continue to rise, the increases in crop production in the temperate zones will not compensate for the decrease in crop production in the tropics and subtropics, ultimately causing global crop yields to decrease. This will increase hunger and famine in many developing nations. In regard to forestry, the additional CO2 in the atmosphere may spur growth, but droughts, fires, incidences of invasive species, and insect and disease outbreaks will cancel these gains. Human health is also at risk. We have already seen an increase in heat waves, and such events cause heat stress that can lead to death. As areas north of the equator warm, there will also be the expansion of tropical diseases, such as dengue fever, because the insects that carry these diseases will now be able to survive in temperate areas. Increased storm surges and flooding can spread disease and create sanitation problems. Also, flooding obviously puts people at risk for drowning. In terms of economics, food will become more expensive because the resources required to grow the food will be scarcer and the conditions to grow crops will be less supportive of high yields. A study published in 2009 reports that future prices of various agricultural products with and without climate change. Even without climate change, the price of wheat will rise 39% from $113 per metric ton to $158 per metric ton. With climate change, the price of wheat would rise 173% to at least $307 per metric ton. This will have significant and far-reaching effects on all nations. Where we live will determine how we experience the impacts of climate change. Here again we will see the dramatic difference poverty and wealth have on human survival and prosperity. The image on the right is a map showing the average temperatures across the U.S. if we pursue a course to reduce emissions, and what we can expect temperatures to look like if we do not reduce emissions. What is clear from this figure is that temperature increases will be much smaller if emissions are lowered. In their 2009 report, the U.S. Global Change Research Program scientists reported and predicted the following climate change impacts for the U.S. Temperature increases 4 to 11 degrees Fahrenheit higher, worse droughts and flooding, decreased crop yields, water shortages, health problems and diseases, higher sea levels, beach erosion, destroyed wetlands, drought, fire, and pests will alter forests, more grasslands and deserts, fewer forests, and undermined Alaskan buildings and roads due to melting permafrost. Temperature changes have been greatest in the Arctic. The ice sheets are melting, the ice is getting thinner, and storms are increasing in number and intensity. A NASA report came out in late October of 2015 that described that while the glaciers in the Arctic are melting rapidly, the glaciers and sea ice in the Antarctic are expanding. Some use this as an argument that global warming isn't occurring, but the flaw in that argument is that global warming is just one type of global climate change, and some areas will experience colder temperatures because of the changes in the climate. Another thought is that the additional ice in the Antarctic will offset the loss of ice in the Arctic. This is also not true because more ice is being lost in the Arctic than is developing in the Antarctic. Some critics will argue that all the science isn't in yet on climate change, that the scientists disagree on what the cause of climate change is, or that scientists still are unsure that it is even happening. These are all untrue. 97% of scientists agree that increased greenhouse gases are causing global warming and human activities are the cause. As was mentioned before, the two main human activities that cause increases in CO2 emissions are, first, burning fossil fuels for energy, and second, loss of carbon-absorbing vegetation due to deforestation. The figure shows the many and varied impacts we currently are experiencing and are expected to experience due to climate change. What is interesting to note is society's response to this information. Despite overwhelming evidence for climate change, many in the U.S. deny what is happening. People debate if it is real and if humans are to blame, and some think tanks and a few scientists question it. The news media presents two sides to every issue, despite the fact critics aren't equally supported by evidence. Furthermore, news media present this issue as opinion up for debate rather than scientific fact that has thousands of peer-reviewed research studies to support it. That concludes this second mini lecture on global climate change. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!